Hello dear students, now we are going to be discuss about the problems related to the division by t. Now look at this here, Laplace transform of f of t by t, the denominator has here t, okay. So this one is equal to, now to remove this t in the denominator, right now we are integral s to infinity, s to infinity, so Laplace transform of the numerator, okay, into ds. Clear? To remove this denominator t, okay, right, integral is to infinity L of f of t ds. Now remember these formulas. Now let's go to the questions. 8 questions are enough. సో వీటిని పక్క ప్రాక్టీస్ చేస్తే మనం వాళ్ళు ఏ క్వశ్చన్ ఇచ్చినా ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ నో వీ కెన్ సాల్వ్ ఈజీలీ. Okay, now here sin t by t, f of t by division by t, here also numerator denominator has having here t, denominator t, f of t here also. Now coming to the fifth question here, integral 0 to t means here the Laplace transform of integral is involved and division by t is involved. Now here coming to the sixth question, Laplace transform of the integral is involved. Okay, we have discussed in lesson number 3. And here e to the power of t means what? First shifting theorem. Okay, we have discussed in the lesson number 2. 1, next to 2, 3. So here 3 formulas involved. Laplace transform of integrals, first shifting theorem and division by t. Next here the seventh one, e to the power of exponential term if it is involved. So then apply the first shifting. Now here we need to apply the first shifting, then division by t. Here also first shifting, next Laplace transform of the integrals, and here division by t. ఈ ప్రాబ్లమ్ సాల్వ్ చేసిన తర్వాత 100% ఏ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ వచ్చిన క్వశ్చన్స్ అయినా మీరు సాల్వ్ చేయొచ్చు ఈజీగా. ఓకే, సో ఐఎమ్ హియర్ యూ టీచ్ ద స్టెప్ బై స్టెప్ ప్రాసెస్. Yes, solution by the division by t, L of f of t by t is equals to what? Integral s to infinity Laplace transform of the numerator, Laplace transform of the numerator into ds. So like that, so this one is equal to, how do we write here? Integral s to infinity Laplace transform of the numerator. The numerator is what here? Sin t, s into ds. Here integral s to infinity Laplace transform of sin t. Sin t is equal to a by s square plus a square 1 square into ds, since L of sin 80, Laplace transform of sin 80 is equals to a by s square plus a square. T coefficient is a here. Okay, now we have integration of 1 by x square plus 1 square into dx is equal to what? Tan inverse x. Tan inverse, here we have tan inverse, yes, here s to infinity. Now apply the upper limit minus lower limit. Now tan inverse of upper limit infinity minus here tan inverse of the lower limit. Now tan inverse of infinity, tan 90, tan inverse of infinity is equal to here tan 90 pi by 2 minus tan inverse of here s. Tan inverse of tan, so then we get here pi by 2 minus here tan inverse of s, or this one is equal to, we can write it as here cot inverse of s, since in intermediate, so we have proved tan inverse x plus here tan inverse x plus here cot inverse x is equals to 1 pi by 2. Okay, now tan inverse x, pi by 2 minus tan inverse x is equal to cot inverse x. So using this formula now it can be written, otherwise we can leave here itself. Okay, let's go to the second one. Here second one, to remove this denominator t, right here integral s to infinity, now Laplace transform of the numerator e power minus at minus e to the power of here minus bt into ds. Now here integral s to infinity Laplace transform of e power minus at 1 by here s plus a minus 1 by s plus b into ds. Clear? So we have integration of 1 by x dx is equals to log x. Okay, so based on this formula I'm writing log of s plus a minus here log of s plus b. Now apply integration of this term, again integration of this term. Instead of x we have here s plus a, so I've written here log of s plus a. Instead of here x we have here s plus b, so I have written here log of s plus b of the lower limit s, upper limit infinity. So here if I apply the limit directly, log infinity undefined, yes, but this integral should be exist. To exist here, log a minus log b form, right? Here it is in the form of log a minus log b is equal to log a by b. Okay, I am writing here log a means what here? S plus a by here s plus b. Okay, and apply upper limit minus lower limit. Now let's see here, if I apply the upper limit, numerator ఏమొస్తుంది infinity plus a, infinity, denominator also infinity, infinity by infinity means what? Undetermined. So here take highest power of s common from the numerator and take highest degree of s common from the denominator. If I here highest degree is 1, so s I am taking as a common, remaining 1 plus here a by s. See in the denominator s as a common, so 1 plus b by s. If I multiply s, then again we can get the remaining term. So here s to infinity. Here s get cancelled out, right? S. So we can get here log of 1 plus here a by s by 1 plus b by s. Now you can apply the upper limit and lower limit. Now we are applying the upper limit log of 1 plus here a by infinity all divided by 1 plus here b by infinity minus of lower limit. What is the lower limit? 1 plus a s lower limit s replaced by s only, 1 plus b by here yes, log of 1 by infinity, 1 by infinity value here is 0, yes, 1 plus 0, 1 plus 0 by 1 plus 0 minus log of, if I do the recalculation again, we get here s plus a by s plus b. If you get confused, just I'm going to write here denominator as here 1. Okay, LCM of 1 comma s is here is right. Now numerator here s plus a all divide, denominator here 1 by 1, 1 comma s LCM is here yes, s into 1 here s, next again here s get cancelled, s plus e by s plus b, log 1 plus 0 log 1, 1 plus 0 by 1 plus 0, 1 by 1, 1 log 1 value is 0, right? 0 minus log of s plus a by here s plus b, or it can be written here log of here s plus a by s plus b all to the power of minus 1, since a log x is equal to, since here a log x is equal to log x to the power of a. Okay, here a, this is what here minus 1. If you remove the negative also power, now here replace here log of s plus b by s plus a. So this is the final answer. Let's go to the next one here, fourth one. Here again denominator having the t, to remove it here apply now division by t, integral s to infinity Laplace transform of the numerator is what? Cos 2t minus here cos 3t of here ds. Okay. Here integral s to infinity as it is. Apply Laplace transform of cos 2t. Cos 2t is equal to s by here s square plus 2 square minus minus Laplace transform of cos 3t. Here s by s square plus here 3 square into ds. Now since I'm writing the formula again, L of cos at. L of cos at is equal to s by s square plus a square. Okay. Next here, when I apply the integration here, integration of s by s square plus a square, integration of numerator having the s and denominator also having the s term. So here we cannot integration u by v formula. So to how do we evaluate this integral function? Let's see here. We have one formula. Integration of f dash of x by f of x. F dash of x by f of x dx is equals to log f of x. Clear? Derivative of the numerator should be in the numerator. Yes, దీని derivative అనేది numerator లో ఉండాలి. F of x derivative should be in the numerator. Clear? So here now identify the derivative of the denominator. S square derivative here 2s. 2 square 4 derivative is what? 0. S square derivative 2s kada. So numerator length undali 2 undali. Here also coming to here, s square plus 3 square 9. S square derivative 2s, but denominator should be 2, but we have only 2a only. So I'm writing the function again here, integral s to infinity here s by s square plus 4 minus s by s square plus 9 of here ds. Derivative of here s square means what? 2s. 2 should be in the numerator. I am writing here 2. Here also I am writing here 2. So before I am writing here 2. Take 2 common. Yes sir. Dividing and multiplying by 2 here. Right? So this one is equal to, now we are 1 by 2 of apply this formula. Log f of x. Okay. Here log f of x means what here? S square plus 4 minus log of here s square plus 9. Now the limits are s to infinity. So can we apply the upper limit and lower limit directly? No, it is completely wrong, because if we apply the upper limit, it goes to log of infinity square plus 4. Log infinity will be there. Log infinity means what? Undefined. But it should be exist. So to exist it, I am going to write here log a minus log b form. Right? Here s square plus 4 by s square plus 9. Again lower limit yes, upper limit infinity. Here also we cannot apply the limit directly because infinity. So if you apply the upper limit, log of infinity square plus 4 by infinity square plus 9. Infinity square, infinity plus 4, infinity by infinity. Here infinity by infinity is what? Undetermined form. Undetermined. So here also we cannot apply the limit directly. So now we are like previous problem, take highest degree of s common from the numerator by highest degree of s common from the denominator. I took here s square common. ఇక్కడ ఏముంటుంది మనకి 1. Next place 4 divides here s square, all divides, taking here s square as a common, 1 plus here 9 by s square. Okay, lower limit yes, upper limit infinity. Here s square and here s square will be cancel out. Yes, so finally we can get here. So apply the upper limit directly. So I'm applying the upper limit, log of 1 plus here 4 by infinity square by 1 plus here 9 by infinity square minus of lower limit. Lower limit is s, 1 plus here 4 by s square by 1 plus here 9 by s square. So here 1 by infinity square, infinity 1 by here we can write 1 by infinity whole to the power of 2. 1 by infinity value is 0. 0 power 2, 0 again. So here 1 plus 0, here we get 1 by 2 half log of 1 plus 0 by 1 plus 0. 1 plus 0, 1 by 1, 1 log 1 value 0. Again minus log of, it goes to again here s square plus 4 divides s square plus 9. So that implies minus this log 1 plus 0, 1 by 1 log 1 value 0. Entire the first term is 0. Now again we get here minus 1 by 2 of, now log of s square plus 4 by s square plus 9. Next, here I am writing here for the space constraint here. Now we have a log x formula. A log x equal to log x to the power of a. So like that, log of s square plus 4 by s square plus 9 all to the power of minus 1 by 2. So this one is equal to remove this negative sign of the power, or reciprocal of it, s square plus 9 by s square plus 4 all to the power of 1 by 2. Or we can write again here log of square root of s square plus 9 by s square plus 4. So this is the way. Next, go to the next problem here. See here, integral 0 to t means what? Laplace transform of integrals, right? So in the lesson number 3 we have discussed here to remove this integral 0 to 2t, right here 1 by s. 1 by s of the remaining here 1 minus e to the power of minus t by t. Yes, now 1 by s is as it is of, to remove this here denominator t, now apply division by t. Integral s to infinity Laplace transform of the numerator 1 minus e power minus t of here d. Yes, right. So 1 by s integral s to infinity L of 1. Laplace transform of 1 is 1 by s minus Laplace transform of e power minus t 1 by s plus 1 into ds. Now 1 by s of integration of 1 by s into ds log s minus integration of 1 by s plus 1 log of s plus 1. Here s to infinity. Here also we cannot apply the limit directly because here we get the infinity by here infinity form. So here log a minus log b, log a by b, s by s plus 1, s to infinity. So 1 by s of, take highest degree of s common from the numerator. Only we have single term only. No need to take common. Denominator has the degree of s is 1. 1 plus 1 by s of here s to infinity. So we get 1 by s of log of 1 by 1 plus here 1 by s. Apply the upper limit, here lower limit as here yes. Okay. Now here 1 by s of log of, if I apply the upper limit 1 by 1 plus 1 by infinity minus log of 1 by 1 plus here 1 by yes. Okay. Here 1 by s of log 1 here 1 by infinity value 0, 1 by 1 1 log 1 value 0 minus here log of, it can be written as again here s by s plus 1. So minus 1 by s into log of s by s plus 1. So clear. So next let's go here. So first of all we need to remove this integral Laplace transform of the integral function, right here 1 by s, okay, of Laplace transform of the remaining term e to the power of t, again here sin t by t, sin t by t. Okay, now here 1 by s of, we can apply the first division by t or first shifting theorem. So first thing, to remove this exponential form, apply the first shifting theorem. S changes to s minus 1. So then only calculation will be easy. Clear? Yes? Enough. So Laplace transform of your entire function here, right? Division by t. Okay, or we can apply here, we can apply division by t, no issue on it. Integral s to infinity, here e to the power of t into sin t, sin t. Sorry, now I'm writing the formula again here. Division by t formula, L of f of t by t is equals to integral s to infinity L of the numerator f of t into ds. Okay. Now 1 by s of integral s to infinity Laplace transform of the numerator e power t into sin t into d. Yes. Now here 1 by s of integral s to infinity of. So here need to apply the first shifting theorem. S changes to s minus 1. Next here L of sin t. L of sin t into ds. Don't get confused. Okay, here I am doing the step by step process. Denominator t is there. ఈ డినామినేటర్ టీని అప్లై చేశాను డివిజన్ బై టీ. తర్వాత ఏముంది, న్యూమరేటర్ ఈ పవర్ టీ ఉంది, సైన్ టీ ఉంది. ఈ పవర్ టీ వచ్చిందంటే ఏంటి, ఫస్ట్ షిఫ్టింగ్ థీరం. సో ఫస్ట్ షిఫ్టింగ్ థీరం చేసేసాను. ఓకే, నెక్స్ట్ అగైన్ this one continuation 1 by s, here integral s to infinity L of sin t. Sin t is equal to 1 by s square plus 1 square. Again here s changes to s minus 1 into ds. So here 1 by s, integral here s to infinity, now 1 by s minus 1 whole square, next plus 1 square into ds. So here 1 by s of integration of 1 by x square plus 1 square formula, tan inverse of s minus 1. So s to infinity. So 1 by s of tan inverse of infinity minus 1 minus tan inverse of here s minus 1. So 1 by s tan inverse of infinity minus 1, tan inverse of infinity. So tan 90, tan 90 is what? Infinity minus tan inverse of here s minus 1. So we get 1 by s of pi by 2 minus tan inverse of s minus 1. So here this one is equal to, or it can be written as here 1 by s into cot inverse of s minus 1. Otherwise you can leave here itself. So like that, now you can find out this one. First apply the division by t. To apply the division by t, now write integral s to infinity Laplace transform of the numerator e power minus 3t. Now here sin 2t of here d. Yes. Now integral s to infinity, to remove this exponential form, right, again here s changes to s plus 3 of the remaining term. So here this one is equal to L of sin 2t into ds. Now here integral s to infinity L of sin 2t, sin 2t a by s square plus 2 square. Again here s changes to s plus 3 into ds. Like previous problem, now you can evaluate this integral function. Okay, now coming to this eighth one. First here we have e to the power of minus 3t. So first thing we need to remove this first shifting theorem. Right here s changes to s plus 3. If it is positive, right here s minus 3 of L of integral 0 to 2t sin t by t, sin t by t into dt. So I am going to remove this integral function. Right here 1 by s, 1 by s, here L of sin t by t, sin t by t all of, here s changes to what, s plus 3. Don't get confused. So first I'm applying the first shifting, then integral of Laplace transform I have applied, then again it has been converted into the division by t. Division by t means what? So I'm going to apply on it only here. So here integral s to infinity Laplace transform of the numerator, right, L of sin t, okay, into ds. Again here s changes to s plus 3. So here this one is equals to 1 by s of integral s to infinity L of sin t, 1 by s square plus 1 square into ds. Again here s changes to s plus 3. So here 1 by s, integration of 1 by x square plus a square. Tan inverse of here s to infinity. Okay. After applying the limit, replace s by s plus 3. So you have 1 by s of tan inverse of upper limit tan infinity minus tan inverse of lower limit s. Again here s changes to s plus 3. So 1 by s of tan inverse of infinity. Infinity can be written as here tan 90 minus tan inverse of here s, again here s changes to s plus 3. So 1 by s of tan inverse of tan 90, right? Now pi by 2 minus here tan inverse of s changes to s plus 3, or this one is equals to, yes, 1 by s into cot inverse of here s, again here s changes to s plus 3. Now replace s by s plus 3. 1 by s plus 3. Now we are cot inverse of s plus 3. I hope you understood clearly. So please like, share and subscribe. Thank you.